Okay, let's go ahead and continue on with our lecture video series. This is going to be 1.3 and 1.4. Okay, frequency tables and experimental design. Hopefully you're acclimating yourself to the course and you figured out how to download the notes properly and do the homework. Okay. If you have any questions about that, feel free to contact me through Canvas and I'll try to get back with you. Okay, let's jump into 1.3. Okay, 1.3, summarizing distributions data using frequency tables. Okay, so what's our objective today? Our objective is to create and read frequency distribution tables, relative frequency distribution tables, and cumulative frequency distribution tables. Number 2, use binning when creating frequency distribution tables. And number 3, create and describe histograms from frequency distribution table of a quantitative variable. Okay, that number 3 we'll be doing in 2.1 actually. Okay, but this 1.3 and 1.4 is going to help us to lay the foundation for chapter 2. Okay, variable. Variable is a label that can take on multiple values. Okay, and what's a distribution? Okay, a distribution is every possible value a variable can assume. And 2, how often that variable takes on those values. Okay, so say I roll a dice and you know, the distribution of the dice would be 1 through 6 because every die that I would roll would have 6 sides. And then the distribution would be, okay, how many times did a 1 come up, or how many times did a 5 come up? Okay, that's the frequency. How frequently did that come up? Okay, what kind of frequency? Okay, how often we see each value? Okay, frequency count. Okay, so this is just a normal count. Okay, this is a count of outcomes. Okay, so that's a count of outcomes. The relative frequency is we divide the total count. We take the count and we divide it by the total. So say that I rolled a die 10 times, but only 4 of those came out as a only 4 of those came out as a 2. Okay, so this would be, so the relative frequency, okay, would be 0.4 or 40%. Okay, so if I rolled 4 2s, okay, so this would be, say, rolling a 2. And if I rolled four 2s, but I rolled a total of 10 dice, okay, then the relative frequency is going to be 4 divided by 10 or 0.4. Okay, it's the part out of the whole. Okay, we divide by the total count. Divide the frequency by the total count. Okay, cumulative frequency. Okay, this means that the frequencies add on to each other. Okay, count the values that are less than or equal to a given value. Okay, and then cumulative relative frequency, the frequencies are summative, they add on to each other, but then we divide by the total. Okay, so we'll get into what the cumulative looks like in a little bit. Okay, frequency table. One common way of organizing and summarizing data is in a table. Okay, this is the categorical variable example. 25 people responded to this question and said, what is your favorite color? Okay, so 10 responded with blue, so we say that 10 is the frequency of blue, and 10 out of 25, divide that on a calculator, we would get 10 divided by 25, and that would be 0.4 or 40%. Okay, so or 0.40, as they're saying there. Okay. Okay, what about red here? Red is 7 out of 25, 7 out of the total. So what's the relative frequency there? Let's go 7 divided by 25, and that's 0.28. Okay, 4 out of 25 for the green. That's 4 divided by 25. That's 16. Okay, and then yellow is 3 out of 25. So what's that going to be? So 3 divided by 25, that's 12.12. And 1 for orange, that's 1 out of 25. It's equal to 1 divided by 25, which is 0.04. Okay. And then the total is 25. Okay. Which would be 25 out of 25 or 100%. Okay, with categorical variable, we cannot find a cumulative frequency because there is no concept of less than. What does it mean to be less than, orange or less than yellow? Is red less than green? We can't order these because it's not numerical data. Okay, let's see. Let's look at some numerical data next. Okay, consider the following GPA of 16 students at their local high school. Okay, so we have a 4.0, 3.8, 3.7, 3.6, 3.6, 3.2, 3.1, 3.0, 2.9, 2.8, 2.5, 2.2, 2.1, 2.0, 1.8, and 1.1. That's nice that they ordered them for us from highest to lowest. Okay, to help us see these things, yet keep it organized, we will use bins, aka classes. A bin is used to count the values that fall within a certain range. Okay, so and we generally will have the lower bound be included. Okay, lower bound be included and the upper bound not be included. Okay, so here the lower bound is included and the upper bound is not included. Okay, so what does this mean? Well, it just means that if I were to look at the bins, right? So the bins are going to be of numerical data are going to be continuous. So we're going to say, well, if we take a bin and we would include 1.0 in that bin, a value of 1.0 in that bin, but we would not include 2.0 in that bin. So if we were to look up here and see, okay, which ones fall between 1.0 and 2.0, but do not include 2.0. 2.0 is not included in this first bin, and in our data, that would be 2 items. Okay, because as soon as we go to that 2.0, we're actually in the next bin. Okay, if we went 2.0 to 3.0, okay, we would actually be in the next bin by including that 2.0. So that 2.0 is included in the next one. It's only the lower bound. That's why we use this bracket here. A bracket means included. Okay, a parenthesis means not included. Okay, think of like a number line. Okay, values on a number line. Okay, lower bound is included and the upper bound is not included. Okay, let's continue with this example. Create bins starting at 1.0 with each with a width of 1. Typically, we include the lower bound and the upper bound because the lower bound for the next bin, but this is a preference, not a rule. It's a preference, not a rule. Okay, so we create bins starting at 1.0 each and a width of 1. So what would our bins look like? Our bins would look like 1.0 to 2.0, but 2.0 is not included. Then we would start on the next one, 2.0 to 3.0. Okay, and then 3.0 would be included in the third one, but 4.0 would not be included, and then we would go 4.0 okay, to 5.0. Okay, so we just created the bins there. Okay, what if we wanted to create bins starting at 1.0 with a width of 0.5? Okay, then we'd have a lot more bins. Okay, then we would say, okay, this is 1.0 is included, but 1.5 is not included. And then we would go 1.5 to 2.0. Okay, we have commas in between these bins. Okay, and then 2.0 to 2.5. And then 2.5 to 3.0. Okay, and then we can just go on like that forever. Okay. Okay, so let's create a frequency table using the bins from part 1. Okay, 1B. Okay, so we have these bins here, 1.0 to 1.5, but 1.5 is not included. Okay. Okay, and then 1.5 to 1.9, 2.0. So let's count how much of this data falls within each of these bins. Well, between 1.0 and 1.4, there's only one, and that's the 1.1. Okay, between 1.5 and 1.9, there's also only one, that's 1.8. Okay, between 2.0 and 2.4, 2.0 to 2.4, it's these three. So that's 3. Okay, between 2.5 and 2.9 included, okay, yeah, that's these. Okay, so that is 3 more. From 3.0 to 3.4. Now, why am I using 3.4 and not 3.5? Because to go to 3.5, I would be in the next bin. Okay, so, and we can only have, one place past the decimal in our GPAs. Okay, that's how we do the GPAs here. So 3.0 to 3.4, yep, that's another 3 here. 3.0 is included in this bin. So 3.0, 3.1, 3.2, that's another 3. 3.5 to 3.9, oh, look at that, that's a big one, that's 4. And then 4.0 to 4.4, there's only one 4.0. Okay, so how many total data were there here? Well, there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces of data. So how do I get the relative frequency? I divide by 16. So I take the count and I divide by the total. So if I were to add this up, the total would be 16. Okay, and so the relative frequency here is going to be 1/16. Okay, and we could change that to a decimal if we wanted to. I'm just going to leave it as a fraction. So 1/16, this is 3/16, 3/16, 3/16, 4/16, that actually reduces. We can leave it as 4/16 if we want, but that will reduce to 1/4. Okay, and then 1/16 as well. Okay, if you were to add up all of those 16ths, you would get 1. Okay, because you would get basically 16 out of 16, which is 1. Okay, let's complete the cumulative rate. Now, how do we do a cumulative? We have to add up all the ones that came before. Okay, all the ones that came before. So if I do 1.0 to 1.9, okay, 1.0 to 1.9, that's these two. Okay, so that's the frequency. Okay, and then what about 2.0 to 2.9? Well, that's these guys here. but it's also everything that came before. Okay, so let's just do the frequencies right now. Let's just do the frequencies, and then we'll do a cumulative next. Okay, so 2.0 to 2.9 is going to be what, 6, and then 3.0 to 3.9, that's 7, and then 4.1 is 1. So how do we do the cumulative? Because we want 1.9 and less for the cumulative frequency. It's everything before, right? 1.9 and less, that's going to be 2. Okay. 2.9 and less, well, that's 2.9 and everything before. That's 2 plus 6, which is 8. 3.9 and less, that's 2 plus 6 plus 7, which is 15. And then 4.9 and less, that's going to be everything. 2 plus 6 plus 7 plus 1, which is 16. So what's the relative frequency here? Okay, the cumulative relative frequency, this is the total pieces of data that we're going to divide by. So that's 2 over 16. Okay, this is going to be 8 over 16. This reduces to 1/8. This reduces to 1/2. This is 15 over 16. That does not reduce. And 16 over 16, or 100%, is the cumulative. The way that we would look at this on a kind of our data would be, for if we had what's called a histogram here, if we had bars representing these values, then on a regular histogram, okay, with just the frequencies, I'd have 1 to 2 to 3 to 4 to 5, right? And I would say, okay, how many are in my first one? Well, it would go up to 2. Okay, 1, 2. Okay, what about from 2 to 3? It would go up 6. So this is 1, 2, 3. Think of it like bricks. 1, 2, 3, 4, 5, 6. Okay, so 6. And then what about from 3 to 4? Okay, 3.0 to 3.9, we're going to have 7. So it's basically the same thing. Okay, but 1 extra. Okay. Okay, so that's 3 to 4. Okay, and then 4 to, that's just 1. So 4 to 5 is just 1. Okay. Okay, so this is what the regular frequency would look like. Okay, what would the cumulative frequency look like? Well, the cumulative frequency, 1, 2, 3, 4, and 5. Okay. And so what would the cumulative frequency look like? Well, it would be, we would be summative. We would be adding the previous ones to it. We'd still start off with 2 of our bricks. Okay, but then on the next one, we would jump to 8. So this would be, 2, 4, 6, 8. Oops. Okay, and then what about the next one here? Well, we would jump all the way to 15. I'm going to run out of space. Let's take this and we would add another 7 to it. Okay, and then what about from 4 to 5? Well, we would add another 1 to that. Okay. So. And another one at the top. So we're adding it all together. Okay, so it becomes summative. Okay, 1.4, other data collection terms. Okay, a prospective study is a study we plan to follow the subjects and collect data in the future. Okay, so thinking forward. Okay, so forward thinking. Example, we identify 6-year-olds in foster care, and each year we will meet them and will assess their academic achievement and ability. Prospective. Retrospective is a study of data collected from the past. So this is behind. Okay, forward or future focused. Okay, and behind would be past focused. Okay, so example, we identify successful entrepreneurs and we go back and look at their grades from their classes in high school. Discussion. Researchers at University of North Carolina were concerned about the increasing dropout rate of the state's high schools, especially for low-income students. Surveys of the recent dropouts revealed that many of these students had started to lose interest in school during middle school. Okay, that's interesting. Okay, they said that they saw little connection between what they were studying in school and their future plans. To change this perspective, researchers developed a program called Career Start. Okay. The big idea is the program is that teachers show students how the topics they learn get used in specific careers. To test the effectiveness of Career Start, the researchers recruited 14 middle schools. 14 middle schools. Okay. In the Forsyth County to participate in an experiment. 7 of the schools chosen at random used Career Start along with the district's standard curriculum. The other 7 schools just followed so we have 14 middle schools participated in the experience. 7 of them, so 7 of the schools were chosen at random and used Career Start. 7 other schools just did the standard curriculum. Okay, so 7 and 7 there. So half of them that were chosen did the Career Start and half of them. Okay. Researchers followed both groups of students for several years, collecting data in the school. Okay, and whether the students graduated from high school. Results, students at the schools that used Career Start generally had better attendance and fewer discipline problems, earned higher test scores, reported greater engagement in classes, and were more likely to graduate. Okay, so this is a prospective study. So this is prospective. Okay, think of it more like an experiment. Okay, a retrospective study would be more like an observational study. Okay, so the experimental units are who is getting experimented on. Who is getting experimented on? Okay, and in this case, it was the students attending the 14 schools. Attending the 14 middle schools. Okay, the variables, what were the variables? Okay, the independent variable, usually what we call the cause. Okay, the independent variable, the cause, the thing that's being varied, is whether or not they use the Career Start curriculum or not. I'll just put Career Start curriculum. Okay, the response variable. Okay, what was the effect? This is the dependent variable. This is the effect. Okay, and so what was the effect? The effect was higher graduation rates. There was also a bunch of other ones that they listed. You know, engagement in classes, higher attendance. But we'll just do the overall on higher graduation rates. Okay. Okay, the treatment. What was the treatment? Okay, the treatment is the action taken on the experimental units. Okay, so there was at seven schools received traditional curriculum, and 7 schools received the Career Start curriculum. Okay, so half of them. Okay, let's do another example here. Okay, what are the effects of repeated exposure to an advertising message? The answer may depend on both length of the ad and on how it is repeated. An experiment investigated this question using undergraduate students as subjects. All subjects viewed a 40-minute television program that included ads for a digital camera. Some subjects saw a 30-second commercial, others a 90-second version. The same commercial was shown either 1, 3, or 5 times. Okay, so there's some variation here, a 30-second versus a 90-second. And whether or not they saw it 1 time, 3 times, or 5 times during the program. After viewing, all the subjects answered their questions about the recall of the ad, their attitude toward the camera, and their intention to purchase it. Okay. So identify the explanatory and response variables. There are 2 explanatory variables. Okay, so 1, what are we varying? Well, we're varying the length of the ad that they saw, and 2, we're varying how many times they saw it. Okay, or how many times they saw. They were exposed. We could call it the exposure rate. Okay, how many times they were exposed to, we'll say an ad. An ad. Okay, ad. Boom. Okay, what were the response variables? Okay, 1 would be the recall of the ad. Number 2, the attitude toward the camera. And 3, whether or not they intend to purchase, the intent to purchase. Okay, list all the treatments. We must combine the 2 factors and get all possible treatments. Okay, so you know, there were 6 different treatments. Okay, so you could have 6 different groups of people. Okay, so they watched a 30-second ad for 1 time, or a 30-second ad 3 times, or a 30-second ad 5 times. They would be in group A, B, C. Okay, D, E, F would be 1 time for 90 seconds, 3 times for 90 seconds, 5 times for 90 seconds. So let's look at all the 6 different ways that they could have been exposed to this advertisement. Okay, so watch a 30-second commercial 1 time is A, watch 30-second commercial 3 times, so C would be watch 30-second commercial 5 times. Okay, D would be watching a 90-second commercial 1 time. Commercial. One time. Okay, E, watch 90-second commercials 3 times, and watch 90-second commercials 5 times. Okay, draw a diagram of how the experiment would play out. Okay, I'm just going to explain. I'm not going to draw a diagram. Okay, say that I choose 60 people for the experiment. Okay, then I could put 10 people in each group. Okay, 10, 10, 10, 10, 10, and 10, right? So 10 in each of the treatment groups. However, I really wouldn't want to choose 60 people. I'd want to choose 70 people. Why? Because I'd want to choose 70 people because I would want a control group in which nobody watched the ad. Okay, and then they were asked about the camera afterwards. So this would be my placebo group. So this would be group A, B, C, D, E, and F. Okay, and then I would have a placebo group, okay, where no ad would be shown. No ad would be shown. And then, you know, arrange them 10 in each treatment group, and then I would record data for all 70 participants. Okay, and see if a trend exists. Okay, does basically more influence imply a higher intent to purchase? Was there a direct cause and effect? Okay. Okay, so that is 1.3 and 1.4. Okay, and I'll see you in the next video.